Okay, students, today we're going to solve logarithmic equations and inequalities. So, notice both these examples, the equations are in logarithmic form. When you only have one side of the equation in logarithmic form and not the other, first thing you're going to do is change it to exponential form. We've already changed things to exponential form. It's the base to that power equals this right there. So 2 cubed equals 2x. Right there, 2 cubed equals 2x. 2 cubed, of course, is 8. 2x equals 8, divided by 2 on both sides, and you get x equals 4. So anytime there's only one log, not two, not on both sides like example 2, but on one side only, you're changing to exponential form. Okay, go ahead and write that down. That's when only one log. Okay, I'm going to erase that now. All right, now when I have a log on both sides, as long as the bases are the same, which they are, and they usually will be, then these values must be the same. So I just set these two equal to each other. So you just have x plus 17 equals, they forgot the x here, so it's supposed to be 3x plus 23, as you see down here. Another error. Okay, obviously you subtract the x across, you get 2x, subtract the 23 across, you get negative 6, and divide by 2, and you get x equals negative 3 for your answer. Now, with logs, what you have to check is check that the answer works. Otherwise, it's called an extraneous solution, as we've talked about before. When I say it works, that when I plug this x in here, this value, after I plug it in, has to be positive, and this value right here has to be positive. As long as they're both positive, then it works. Okay? If they're not both positive, it doesn't work. You cannot have a negative answer right there. Okay? The x values are always positive. This is domain right here. And domain, remember for our normal log, it looks like this. Okay, so all the x values, the domain is x is greater than 0. So it has to be positive. Okay, that's why. All right, if you need to write that down, you can write down. Okay, so that's what you're doing here each time. Okay, you may have a quadratic like you do here. I said x squared minus 6 equal to 2x minus 2. I have a quadratic, so I set the entire equation equal to 0 and solve, which then be either factoring or quadratic formula. So if I do that here, I'll just do this number 8 here. So this equals that, set equal to 0. So I have x squared minus 2x. I'm subtracting the 2 across, gives me minus 8 equals 0. Now that factors nicely into x plus 2 and x minus 4. And so x equals negative 2 or positive 4. Now I have to check again to make sure that I'm going to get a positive answer in both of these. When I plug in this one, I get 4 minus 6. When I plug in this right here, 4 minus 6 is negative 2. That doesn't work. And negative 4 plus 2 is negative 2. Okay? Again, can't have negative there. So, therefore, this is an extraneous solution. But 4 does work. 4 squared is 16 minus 6 is 10. and 4 times 2 is 8 plus 2 is 10. They're both positive. So there's my answer, 4 only. Okay. So if you want to see that, grab a calculator here. Come on. There we go. So remember we got log, it came out to be -2. Base 2, it doesn't matter what base is, the same base, I can use log base 10 of -2. Notice you get an error, non-real answers. Can't have it. Okay, so there it goes to show you no negatives for logs. Okay, let's erase that now. Next page. Solving logarithmic equations and inequalities. Now we're doing inequalities. Okay. So again, remember for inequality, it has to be greater than 0. We just talked about that, right? That's why you see change to exponential form, 5 to the third. Okay, over here now is greater than 4x minus 3. And 4x minus 3 also has to be greater than 0. Because remember, you have to have a positive answer. So that's 125 plus 3 is 128 divided by 4 is 32. And add 3 across divided by 4, we get 3/4. So x is greater than 3/4 and less than 32. Solution set, call that because it's in set notation. Remember, I have these brackets like this. That's called set notation. Okay. Solve the inequality. So again, we see the bases are the same, logs the same. So now we just go ahead and solve that inequality. Okay. And so you're going to subtract the x across, add the 4 across, 2x equals, there's less than 5, x is less than 5 halves. Now, don't forget, they both must be positive. For the lower bound, so it's less than 5 halves, they both must be positive. Okay, so therefore I also have to set each one of these greater than or equal to 0. 3x minus 4 is greater than 0, so it makes x greater than 4/3. In this one, x plus 1 is greater than 0. It makes x greater than -1. So it has to satisfy both of these. Obviously, this is a larger number, so it has to be greater than 4/3 and still less than your 5 halves right there. Okay, so this is a major concept to understand, that you have to always set your log equation also greater than 0. Okay, so you're not just solving that, you have to remember to set each one because both of these have to be positive answers. So you solve both of them greater than or equal to 0 and find out whichever answer is bigger, and it has to be that one. Okay, otherwise it won't satisfy both. Okay, let's see, is there another example? All right, nope, that'll do it right there. So just remember those setups like that. 9 minutes.